Okay, guys, math 3 notes. So we're going to put in today inverse functions. Again, I have pre-written these, so if I go too fast, please just pause to catch up with the writing. Okay, so here we go. So inverse functions, regular lines. We're the first page we're going to dedicate to it being done algebraically. So inverse functions undo each other. And let me zoom in a little bit. And inputs, the domain, and the outputs, the range, trade places. So the math way of writing that is if I plug A into F, I get out the answer B. So A is my domain, B is my range. Into the inverse, if I plug in B, I should get out A. So the first problem we're going to do, algebraically, is to find the inverse of f of x is equal to 2, x plus 4 squared minus 8. So the first way I'm going to do it is to do the forwards and backwards, writing the steps. So we're going to pretend I plug in a number. So if I was to plug in a number x, the first thing we would do would be add 4. And then after we've added 4, we would have to do exponent, so parentheses, and then exponent, so square it. So we'd have to do that number squared. And then from there, we'd have to multiply by 2, so times 2. And then we would have to subtract 8. So backwards, the last thing you do is the first thing you're going to do. But we're going to undo it. So the last thing we did was subtract 8. So the first thing we're going to do is to add 8. So I could actually build this as I do it. So I'm going to take x and I'm going to add 8. And then the next thing was multiply by 2. So backwards, we're going to divide by 2. So divide that by 2. And then the undoing of squaring would be to square root. So we're going to square root that. And the undoing of adding 4 is subtracting 4. So we're going to undo that. So minus 4. And now all we have to do is use function notation to name it. So it's f. Our notation is with the -1 of x. That implies that it is the inverse. So the other thing you can also do to check it is if we plug in a number. So if I was to plug in a number to f, so if I plugged in 2, if we followed order of operations, 2 plus 4 is 6. 6 squared is 36. 36 times 2 is 72. 72 minus 8 is 64. Which means if I'm correct, I should be able to plug in my range as my new input. So I'm going to plug in 64. And I should get out the answer of 2, but let's check. 64 plus 8 is 72. 72 divided by 2 is 36. The square root of 36 is 6. And 6 minus 4 is 2. So it works. Now the math way of writing that is if I plug in 2 into my original function, and then I take this answer and plug that answer, because f of 2 is 64, if I plug that answer into its inverse function, I get the answer 2 out. So we started by plugging in 2, put it into the function, put it into the inverse function, and ended back at 2. So we started at 2, we ended at 2. Okay, second one. These are the steps, and we're going to go through them. So find the inverse of g of x is equal to 2 times x divided by 3 minus 1. So to do this algebraically, this is the way we're going to switch x and y if you're more comfortable with this way. I like to put both of them in the notes. So the first step is to change g of x to y. So g of x is going to become y, and that's equal to 2 times x divided by 3 minus 1. Our second step is to actually switch x and y. So this is now x is equal to 2 times y divided by 3 minus 1. And now we're going to solve for y. To do that, we're just going to undo. So this is 2 times. We're going to divide both sides by 2. I'll do this in blue. Divide both sides by 2. So I've got x divided by 2 is equal to y over 3 minus 1. Now I'm going to add 1 to both sides. Those are unlike terms. So we've got x divided by 2 plus 1 is equal to y over 3. And now we're going to multiply both sides by 3. And here you can actually distribute the 3, or you can leave it out front. I'm just going to leave it out front. So we've got 3 times x over 2 plus 1 is equal to y. Our last step is just to replace y with the inverse notation. And I personally like to write this first, so I'm just going to put the y over here, but it's not really y. It's the inverse of g is equal to 3x divided by 2 plus 1. Okay, so the other way we're going to talk about is graphing, what they look like graphically. So functions and their inverses are symmetrical over the line y is equal to x. I'm even going to highlight that. Let's highlight that. Okay, they are symmetrical over the line y is equal to x. So we're going to graph h of x is equal to x minus 3 divided by 5 and its inverse. So I'm going to do that by plugging in some numbers. So I'm going to plug in negative 2. Negative 2 minus 3 is negative 5. Negative 5 divided by 5 is negative 1. The next number I'm going to choose to plug in, I'm specifically choosing numbers that make the math easy. I'm going to plug in 3. So 3 minus 3 is 0. 0 divided by 5 is 0. I'm going to plug in 8. 8 minus 3 is 5. 5 divided by 5 is 1. And I'm going to plug in 13. 13 minus 3 is 10. 10 divided by 5 is 2. So I'm going to go ahead and graph those. I'm going to use blue for this one. So negative 2, negative 1, 3, 0, 8, 1, 3, 4, 5, 6, 7, 8, 1. And it's going to be off the chart for the next one, which is fine. So here's g of x. I'm going to mark this as g of x. So for a number from in class, we know that our domain, or from our notes from the first part, our domain becomes the range and the range becomes the domain. So I can just flip them. So for our inverse, it would be negative 1, negative 2, 0, 3, 1, 8, and 2, 13. So negative 1, negative 2, 0, 3, 1, 8, and that second last one's also going to be off the line, which gives me this line right here, which is the inverse. Oh, this isn't G. Whoops, it's H. I'm sorry. If you guys wrote G, fix it. My bad. This is H of X, and this is going to be inverse of X, of H, sorry. Now, the other thing I want on here, though, is just to remind you of the line of symmetry. Y is equal to X. So Y is equal to X is this line right here. Okay, I put it in pencil so it looks slightly different. I will also make it more of a dashed line. So we know that this is Y is equal to X. Okay, that's how you do it graphically. The other part that we have to put in our notes is when we have to restrict domains. And it doesn't happen often, but it does happen. So we're going to restrict domains. So we're going to graph p of x, which is x squared minus 3, and its inverse. But we're going to have to restrict our domain on this one. So I'm going to start with p of x. And if you know anything about square roots, our squares and their shape, we know it's going to be a parabola. So for right now, I'm not going to restrict it. I'm going to restrict it at the end and talk about it. So I'm going to plug in, let's say, -3. -3 squared is 9. 9 minus 3 is 6. -2 squared is 4. 4 minus 3 is 1. -1 squared is 1. 1 minus 3 is -2. 0 squared is 0 minus 3 is -3. 1 squared is 1 minus 3 is -2. 2 squared is 4 minus 3, which is 1. And then positive 3 is also going to be 6. Now, I'm going to graph this and maybe wait to copy it so that it makes sense to you. I'm going to graph this. So we've got -3, 6. So -3. 1, 2, 3, up 6, 1, 2, 3, 4, 5, 6, -2, 1, 0, oh, -1, -2, 0, -3, 1, -2, 2, 1, and 3, 6. Okay, so you can see a parabola, and I'm going to do it really lightly because I'm going to erase some of it. So I'm going to actually go ahead and do the y is equal to x, which is right here for the most part. That wasn't the best. Okay. Now, if I was to reflect this, it would reflect it would be a sleeping parabola. It would be on its side. But square roots never have actual negative answers. So you can only have the positive ones. So if I plug in 6, I have 2 spots where I can plug in 6. I cannot have the negative answer. So we're not going to do this one. So 6, 3. Okay, is going to be its inverse. I'm going to do that in red. 6, 3. Now notice I could plug in both ones, but I can't have the negative as an answer, so it has to be 1, 2. I can't plug in, why is that? -2s, but I can't have a negative answer, so I'm going to go with a -2, 1, and then here the -3 will switch. -3, 0. So we have to restrict our domain that this doesn't actually exist. So if I graph these, -3, 0, -2, 1, 1, 2, and 3, 6, or 6, 3, oh, 6, 3, 1, 2, 3, 4, 5, 6, up 3. Okay, which means this is its reflection, so I can use these numbers. So that's the 2 inverses. So the part that we actually didn't use was the negative x values over here. So we're going to restrict our domain to x has to be greater than or equal to 0. So it wouldn't be anything less. So basically this whole part of that graph doesn't exist because it wouldn't be a reflection because square roots are only the positive part of a sleeping parabola. Okay, make sure you have your notes.